All right, so in my opinion, I mean, the good thing about 3-4 is it wraps up everything you've been doing up to that point. So you're forced to review the sections from 3-1 to 3-3 within 3-4. The hardest part for most kids is trying to figure out what to do with the individual problems, right? How to approach them from the beginning. So I just wrote out kind of what the 4 major different kinds of problems are, which is similar to what was on the end of yesterday's slides, okay? A little bit different. So the first kind is if you've got an exponential expression. So you've got something that's being raised to a power on both sides of your equal sign. Could be an e, it could be a base like 2, it could be bases that are different, okay? And if they're different, then, and you can make them the same base, then you just have to use the one-to-one property. So if it was like 2 on the left and 4 on the right, I would change 4 to be 2 to the second power, solve it, that kind of thing. If you can't make them the same base, which I'll show you an example in a little bit, then you will ln both sides of your equation. So I said it in yesterday's video, but we're making ln almost like a verb. We're finding the natural log of both sides of the equation, but instead of saying that whole thing every time, we're going to say that we're going to ln both sides of the equation. The second type is if there's an e on one side of the equal sign. And so when you have that situation, you're going to isolate the e, and then you're going to ln both sides of your equation. The third type is if you've got a log or an ln on one side of the equal sign. And for those, you're going to convert that into exponential. Remember that log is the same thing as log base 10, and ln is the same thing as log base e. And then the last kind is if you've got a log or an ln on both sides of the equal sign. And for those, you're going to use the one-to-one property to solve. So whatever's next to the log, you would set equal to each other, whatever's next to the ln. And for these, you might need to condense them first. So you might have 2 logs on one side, you're going to condense them down to 1, and then use your one-to-one property. So those are kind of all the different kinds that you've got going on. All right, so if you think about what we just talked about with each of these approaches, right? So if you look at it, just says solve for x. When you get to that point, it's literally going to loop them all together. You're going to have to figure out what strategy to do, okay? And then I'll work them out as far as we can without a calculator so you could see what that would be like, because you're going to get some solving without a calculator, and then you're going to get some solving with a calculator. So you can see both, okay? So number 1 says 2 times e to the x minus 3 equals 10. What's your approach to this one?
You put the 3, you add the 3 to the 10.
Good. So what are you working to do? Isolate the e. There's only one e, so this isn't a change of, this isn't a change of base, or this isn't a one-to-one property. There's only one e, so our job is to get that e by itself. So you're going to add the 3 to the other side. I'd get 2e to the x equals 13. And then I'm going to divide both sides by 2. And I get e to the x equals 13 over 2. How do I get rid of that e? You're going to ln both sides of your equation. So I'm going to ln e to the x, and I'm going to ln 13 over 2. What happens to ln of e to the x? Good. Cancels, leaving you the exponent. So I get x equals ln of 13 over 2. If you didn't have a calculator, that's as far as you're going to get. And that might happen. It might be to a point that you do it as far as you can possibly get, or it might say, this is on the part where you have a calculator, round that answer to 3 decimal places. So you want to make sure you're prepared for both. So I would do ln of 13 divided by 2, and I get 1.8718, which is 1.872. So again, be prepared for both. That could be solved as far as the ln of 13 over 2 without a calculator, and then with a calculator you'd get to the actual rounded answer. Questions on that one? With a calculator, this is easy to check, right? I would just plug in my calculator, 2 times e to the 1.872 minus 3. It's a rounded answer, so it might not be exactly 10, but you're going to get pretty close to 10. All right, now look at 2. So 2 has 1 log on one side of the equation, which means I do what? Convert it into exponential, right? Log is log base 10. 10's going to come over and pick up the 2. Drops off, leaving the 4x. This is 100 equals 4x. Divide both sides by 4, and x equals 25. Totally didn't need a calculator on that. If there's a question like that, it's going to be on the part you don't have your calculator, okay? But when you start with a log, you have to check these answers. So I want to take this 25 and I want to plug it back into the x. I don't have to go through the exact steps. I can, because it's easy to check. I can do 4 times 25 is 100. Log base 10 of 100 is 2. Good, I got the right answer. But what you're really checking for is to make sure is when you plug it back into your variable and you simplify that is not 0 or negative. If when you simplify what's next to the log, you get a 0 or a negative, you rule out that answer, it cannot work. And you won't know it unless you check. Okay? Usually it doesn't come into play unless it's a quadratic. But you always want to take the time to check because they're special cases. So this time my answer would be x equals 25. Questions on that one? Okay, then I get to 3. Log base 3 of 5 plus log base 3 of x plus 2 equals log base 3 of x plus 6. Now I've got a log on either side of my equal sign, right? Which means I have to do what? Condense it, and then it's going to be 1 to 1, right? So I'm going to condense the left side. If it's addition, it becomes what? Multiplication. So I get log base 3 of 5 times x plus 2 equals log base 3 of x plus 6. Now I've got one log with the same base on either side of my equal sign, which means ignore it and grab what's next to it, setting it equal to each other. So I'd get 5x plus 10. Once I distribute that 5 equals x plus 6. Subtract the x from both sides. I get 4x. Subtract the 10 from both sides equals negative 4. Divide both sides by 4, and I get negative 1. And because there are logs in my initial question, I check this answer. If I take the negative 1, there's nothing to plug in here, so I don't have to worry about that one. If I take the negative 1 and plug it into x on that second one, negative 1 plus 2 is 1. Positive, totally fine. Take the negative 1, plug it in here. Negative 1 plus 6 is 5. That's still positive, so it works. Okay? So it's not necessarily that you're ruling out every negative number or every 0. It's if you plug it back in and you simplify what's next to the log, does that give you a negative or a 0? That's when you would rule it out.
And if it gives you a negative or a 0?
You just kick it out. Like it's not like it's called an extraneous root. It doesn't work. Yep. Questions on any of the warm up? So I said I was going to do an example with like one that the bases are not the same and you can't change them. So if I had something like 2 to the x equals 3 to the 5th. They're both exponential, right? But there is no way to rewrite 3 as 2 to a power. That's a whole number anyways, right? This is when you have to ln both sides of your equation. So if I ln the left and I ln the right, it says ln of 2 to the x equals ln of 3 to the 5th. What do I do with my exponents when I'm expanding? I put them at the front. So this would be x times ln of 2 equals 5 times ln of 3. Now my goal is to solve for x. So how do I get the x on the left on the side by itself? Divide both sides by ln of 2. So without a calculator, this is how it would look. Oops. And with a calculator, you would work that out. 5 times ln of 3 divided by ln of 2. And I get 7.9248 or 7.925. Questions on that? So if it can be changed, if it was a base on the left that was a 2 and a base on the left that was 64, I can change that so that they have the same base. But if they can't be, then you have to ln both sides of the equation. Your exponent always gets bumped to the front and then solve by getting it separate from the x. Questions from the homework. So I got a couple emails last night that people got some that got stuck. So I pushed the due date to tomorrow if you need to redo it or finish it. And if you've got questions, please ask now. Now would be a good time so I could help everybody with them. Han. Can you read what yours says?
Log 3 to the x.
Like that?
Yeah.
Yep.
Plus log 3, parentheses, x minus 8 equals 2.
Okay, so log's only on one side of the equation, right? If it was on both, I'd condense and then do 1 to 1. But because it's only on one side of the equation, I'm going to condense, but then I have to do exponential. So I want to condense them both. Log base 3 of x plus log base 3 of x minus 8 becomes log base 3 of x times x minus 8 equals 2. Then 1 log means I can change this to exponential. 3 is going to come over here, pick up the 2, equals, this goes on the other side, x times x minus 8. And then this is 9 equals x squared minus 8 times x. As soon as you see the squared and the x, you should know you're going to have to get this to one side and try to factor it. So subtract the 9. 0 equals x squared minus 8x minus 9. Are there factors of negative 9 that sum to negative 8?
Mm-hmm.
Yep. Negative 9, positive 1. Set them each equal to 0. And x equals 9, and x equals negative 1. So my initial question had a log in it, which means you got to check those answers. If I take 9 and I plug it into this x, it works. If I take 9 and plug it into this x, it works, meaning it's not negative or 0. If I take negative 1 and I plug it into this x, I'm trying to find log of a negative number, and it can't happen. So I rule out the negative 1, and the only one that works is 9. Sophia.
So, question, do I
Read it to me.
e to the second power times x, so like 2x,
Yep.
minus 8e to the x powers,
Yep.
plus 12 equals 0.
Okay, so these are factoring questions in disguise, right? They look a lot sloppier than they need to be. E to the 2x, when you factor that out, is just e to the x times e to the x. Because if you think about when you multiply those two together, x times x is 2x, right? You add the exponents. So then I'm looking for the factors of positive 12 that sum to negative 8. So positive 12 would be 1 and 12 and 2 and 6. And they both have the same sign, so I can use negative 2 and negative 6. If you check that, that's negative 6e to the x and negative 2e to the x, and together that gives you negative 8 to the x. So you know you did it right. Now, if either of those are 0, the whole thing's 0, which means I have to split and solve them. Set this one equal to 0 and set this one equal to 0. So I get e to the x equals 2 and e to the x equals 6. How do you solve an e to the x problem? ln both sides of your equation. So ln of 2, ln of e to the x, ln of e to the x, and ln of 6. What happens with ln of e to the x? Cancels, just leaving you x. Cancels, leaves you x. So without a calculator, you'd be done. With a calculator, it's ln of 2, which is 0.693, and ln of 6, which is 1.792. So the e's you can check, but you don't have to. The logs you have to check, or an ln you have to check, because those are the ones that have the extraneous root. Nick. Okay, so 1 ln, right? Not 1 on either side, so I'm not doing 1 to 1. This is go from log to exponential. So ln is log base e of 3x plus 6 equals 5. I want to convert this into exponential. E to the 5th equals 3x plus 6. And then you can actually find e to the 5th on your calculator, but let's go as far as we can without, right? So it would be e to the 5th minus 6 equals 3x, and then divide everything by 3. So without a calculator, it's messy, but it would be this, which actually can even be simplified. But most likely, that kind of question, you're going to have a calculator. So you would take this and make it e to the 5th minus 6 divided by 3, which is 47.471. You're welcome. Sophia.
ln open parentheses x plus 6 close parentheses minus ln open parentheses x minus 4 close parentheses equals ln
of x, right? I was waiting for this one. Okay, you got two ln's on both sides of the equations now. So you gotta work it till the one-to-one property can be used, which means you've got to condense the left side. So if I condense a subtraction of logs, it becomes what? Division. So x plus 6 over x minus 4 would equal ln of x. As soon as I get that one ln on either side, I ignore those and set what's equal to it, or what's next to it equal to each other. And then I need to solve. So I'm going to multiply both sides by x minus 4. It's going to cancel from here. X plus 6 equals x times x minus 4, x squared minus 4x. Again, hopefully a little red flag goes off as soon as I see squared and x to the first. I'm going to try to get everything to one side and factor it. So if I subtract the x and the 6, I end up with 0 equals x squared minus 5x minus 6. So see if you can factor it. This one can be right. This would be x minus 6 and x plus 1. Some of the questions couldn't be factored. If it can't be factored, how do you solve a quadratic? Quadratic formula, right? Negative b, that whole thing. So if it's not factorable, then you have to use quadratic. This time you could. So this would be positive 6 and negative 1. And then again, because it started with ln, which is a log, you have to check the positive 6 and negative 1 in each of these places. So 6 would be 6 plus 6 is 12, that's fine. 6 minus 4 is positive 2, that's fine. 6 by itself, that's fine. So this one works. Plug in the negative 1, and negative 1 plus 6 is 5, that's fine. But negative 1 minus 4 is negative 5. As soon as you get to that one and it doesn't work, you can rule out the negative 1. So if it doesn't work on any of the logs at the beginning, you rule it out. It's not all of them, it's any single one of them. Ben, you had your hand up. Was it the same question? Okay. Hannah.
Can you scroll up to the next question?
Mm-hmm.